Hi, so today we're going to be talking about a new property which is called the zero product property and how we can use that to solve equations. But we're also going to be talking about how what we learned yesterday about reverse distributive property is going to help us solve equations like this. Okay, so the first thing I want to do is, I know we have this kind of idea discussion here right now, and if you want, you can take a moment and pause the video, read these statements over, and then just write what you think you would be able to tell me about the numbers that you were thinking about. Okay, hopefully you're done doing that, and you're back with us. So I want to mainly focus on the second one, and it says the product of two numbers is 0. What can you tell me about those numbers? Okay. So if I'm multiplying two numbers, let's say a times b equals 0, then what they're saying is that if this equals 0, then there is something that I should be able to say about these numbers, or at least one of these numbers. Okay, when I'm thinking about multiplying, if I take a number and I multiply it by a fraction that's less than 1, then I know the number gets smaller. If I take the number and I multiply it by some number that's bigger than 1, then I know that my answer will be bigger. But my question is for you, what type of number do you need to multiply by in order to get it to equal 0? And hopefully you realize that, well, if this equals 0, then what we know is that a has to equal 0 or b has to equal 0, because that's the only way that I'm going to get 0 for a product. Now, if we take that to mean exactly as we state it, then what we're saying is essentially the entire zero product property. The zero product property tells us that if the product of two values is equal to 0, then one of the values must be equal to 0. If the product of two values is equal to 0, then one of the values must equal to 0. So what we're going to do next is we're going to take a look at two problems where we have a product of values and the product is actually equal to 0. So I'm going to look at this first problem here. I have x minus 10 times x over 2 plus 20. So I can see that I have two items that are being multiplied by one another. I have x minus 1 times x minus 2, which means this is a factor, this is a factor, and 0 is their product. So if I have two factors equal to 0, what I want to do is I want to take each factor, 1, 2, and I want to set them individually equal to 0, which lets me get x minus 10 equals 0, or, fancy compound statement here, x over 2 plus 20 equals 0. When we do that, we can solve each of these much simpler equations without much hassle. So we find x equals 10, x over 2 equals negative 20, so multiply both sides by 2. Remember, multiplication undoes division, and this gets us x equals negative 40. Which means that we know our answer is x equals 10 or x equals negative 40. Let's go ahead and take a look at this second problem. So this second problem, again, we have two items that are being multiplied. We have x minus 4 and x plus 3, and it's equal to 0. So if I wanted to spell it out again, this is a factor, this is a factor, and this is their product. So if you have some factors and their product is 0, then you should use the zero product property, which says that if you're multiplying two things and it equals 0, then one of those things has to equal 0. So in order to figure out which one it is, we actually take both of them, x minus 4 equal to 0, there's one factor equal to 0, and x plus 3 equal to 0. We set both of the factors equal to 0. We set each of the factors equal to 0. Because this gives us a straightforward, actually two straightforward, simple equations that we can solve. Add 4 to both sides, take away 3 from each side. You find that x equals 4 or x equals negative 3. So these are the solutions or possible solutions to this equation based on using what we know. Okay, so you may be looking at these two problems and thinking, oh, well, they were already in their factors equal to 0. That's really easy. Okay, so we're going to look at next what happens when things are not being multiplied. Okay, so if you felt like you were being pretty successful in the last lesson, then this is your time to shine. Because what we have here is we have an instance where we have to take either an addition statement or a subtraction statement and somehow turn it into a multiplication statement, which is exactly what we did yesterday using the reverse distributive property. It's exactly what we're going to do today for 3 examples before you get to your group work. Okay, so take a look at our first problem. We have 2x squared minus 10x is equal to 0. So I do have an expression that's equal to 0. Sadly, this expression is not made up out of 2 factors. It is made up of 2 terms. Terms are separated by addition or subtraction. Factors are separated by multiplication. Okay, so looking here, I know this is not factors, but I can use reverse distributive property to make it look like factors. So I'm going to split this up, 2 times 1 times x, hopefully you remember that, and 2 times 5 times x. When I do this, I see what they have in common, too big. I see what they have in common, 2x, and everything else gets left out. So 2x times x minus 5. So when I do that, what happens is that now we actually have 2 factors. Factor, factor, equal to 0. If I have that, then I need to take each factor and I need to set it equal to 0 individually. This allows me to have 2 very simple equations that we can solve pretty quickly. Which leads us to our final answers. This equation is true when x equals 0 and x equals 5. This equation is true when x equals 0 and x equals 5. Let's do another example. So again, here I have a statement that's mainly an addition statement. I'm seeing this addition separating these 2 terms. Okay. Luckily, we did quite a few problems like this yesterday where we noticed, oh, the x minus 3, that's what they have in common. So we pulled that out, and when we did that, we found that what we had left was actually x plus 5. Okay, once we do that, we can see now that what we have here is factor, factor, and their product is 0. So if you have 2 factors and their product is equal to 0, then you use the 0 product property. You set each factor equal to 0, and you solve each of the new equations that you have. Okay, so x equals 3 or x equals negative 5. That means this equation is true when x equals 3 or when x equals negative 5. Okay, we're going to do our last example and then I'm going to show you to your group work and we will get started. So take a look at this last problem. If you feel like you can do all the steps you need to, go ahead and do them on your own. I'm going to quickly review what the steps are for the rest of us, just so we have a reference going into our group work. Okay, so if you have addition statements, the first thing you're going to want to do is you will want to, you might want to write this small. You might want to reverse distribute if you need to. So looking at this problem, I can see that I definitely need to reverse distribute because I have 2 terms separated by addition. That's not what I want. So I'm going to reverse distribute this. This is 3 times 1 times x, and here we have 3 times 9 times x. So hopefully right now you can see what we need to take out, 3x, and what we need to keep in, x plus 9. Okay, the second thing you want to do is you want to set each factor equal to 0. So here I have the entire equation is equal to 0, but I should set each of these factors separately. So there are two factors. Multiplication separates factors. So we have 3x equals 0, or we have x plus 9 equals 0. That gives us two simpler equations. Our next step, solve both equations. So if I solve both equations, divide by 3, we should know that any 0 divided by any number is still going to be 0. Subtract 9 over here. We find x equals -9. So your last step is that you're done. Okay, this is our solution. This is going to be a true statement when x equals 0 or when x equals 9. Okay, you'll see that we have one more problem here as an example, and this really just isn't in a priority, so I'd rather us get to practice than spend a little bit more time going through this example. If you're interested in this, though, let me know and I can explain it to you. So on the next page, what you're going to see is we have some group work problems. What I want you to do is do these two problems, check with the video, do these two problems, check with the video, do these two problems, and check with the video. Okay, get to it.